Welcome to The Explainer. So today, we're going to talk about something really different, a revolutionary way of thinking about logic itself. It's a system where proofs aren't just these abstract, eternal truths, but they're actions with real consequences. We are talking about linear logic.
Okay, so let's just dive right in. In the world of classical logic, the logic most of us are taught, if you prove something is true, well, you can use that fact over and over and over again, as many times as you want. But that's not how the real world works, is it? You can't spend the same dollar twice. Once it's gone, it's gone. And that huge gap between abstract truth and physical reality, that's right where our story starts. You see, the real issue here is that traditional logic kinda has an infinite resource problem. It's built on this core assumption that you can always grab any proven fact whenever you need it, with zero consequences. It's like drawing water from a magical, endless well. Now, I don't want to get too deep in the weeds here, but this whole infinite quality really comes from two fundamental rules. Think of it this way. A rule called weakening is like having a fact in your pocket that you can just choose to ignore if it's not useful. And another rule, contraction, is basically a magical duplicating machine for facts. You can use a fact once, or 1,000 times, or 1,000,000 times, it doesn't matter. These rules are the absolute bedrock of classical logic, but they just don't line up with a world where things run out. So what's the solution? Well, let's fast forward to the 1980s, when a French logician named Jean-Yves came along and proposed this radical new system, a logic that was built from the ground up to be resource-aware. And he called it linear logic. Now, it's a substructural logic, which is really just a fancy way of saying it throws out those automatic ignore it if you want and copy it forever rules. In linear logic, every single assumption is a resource, and you have to account for it. It has to be used exactly once. No leftovers, no copies. And that changes everything. The crucial point here is that a proof is no longer just some abstract path to a truth that exists forever. No, it becomes a process. It's a transaction that consumes inputs to produce an output. It's all about transformation, not just piling up facts. Okay, I know this all sounds super abstract, right? But what's really cool is how we can understand this whole shift using a super simple, everyday analogy. Just picture yourself standing in front of a vending machine, or maybe ordering from a set menu at a restaurant. And hey, this isn't just some random example I pulled out of a hat. This has become the absolute classic way to explain linear logic. Why? Because the act of paying for something and then receiving a specific item, it perfectly captures this idea of consuming one resource, your money, to produce another, your meal. This whole idea is called the resource interpretation. We basically stop thinking of a logical formula, let's say A, as a statement that's just true or false. Instead, we start thinking of A as a thing, a resource that we have that we can use and that we can spend in a transaction. So let's see how this actually builds a whole new logical language. The operators in linear logic, what they call its connectives, they act like different choices you have on a restaurant's special prefix menu. First up, we've got something called the tensor product. You can think of this as getting an appetizer and a main course. It means you get both of them together as a complete package. You're combining two totally separate resources into one deal. But wait, there's another kind of and. This one is called with, and it represents a choice. So if the appetizer on the menu is listed as soup and salad, it doesn't mean you get both. It means you have to pick one or the other. You're using your one appetizer resource to get just one of two possible outcomes. And this comparison just illustrates the difference perfectly. On the left, with that tensor symbol that's getting a coffee and also a croissant, you've paid for two separate things. But on the right, with the with connective, the meal deal forces you to choose. You get the coffee or the tea. See? Classical logic only has one version of and, but the real world is filled with these two different kinds of combinations. Okay, so what about things that are limited? Like the truths of classical logic? Well, linear logic has a brilliant answer for that too. It's an operator called of course, or sometimes just bang, and it marks a resource as infinite. Think of it like the free tap water you get with your meal. You can have as many glasses as you want, or you can have none at all. It's the system's way of carefully and deliberately letting you duplicate and discard, but only when you explicitly say so. So let's do a quick recap of our logical menu. We've got the tensor, which combines separate things. We've got the with, which gives you a choice. And we have the exponential, which gives you an unlimited supply. And that's pretty much the basic toolkit for building these resource-aware statements. All right, I know this might all seem like a really beautiful, but maybe purely abstract thought experiment. But it turns out this way of thinking has had a massive impact on a bunch of different fields, precisely because it's so good at modeling processes in finite states. So in computer science, for example, it's used to design programming languages that can handle things like memory, a very finite resource, safely and efficiently. In quantum physics, believe it or not, its structure has these incredibly deep connections to the bizarre behavior of quantum information. It's even used in linguistics to model how our brains parse sentences by consuming words to build up grammatical meaning. It's everywhere. Now, it is really important to remember, this isn't about replacing classical logic. Not at all. It's about refining it. By using that of course operator, linear logic can perfectly simulate classical reasoning whenever it needs to. It basically contains the old world inside of this new, more detailed, and more realistic one. So that's linear logic, a system that brings logic crashing down to earth. And it leaves us with this really fascinating question to chew on. What new possibilities could we unlock? What could we build if our computer programs and our systems, from the ground up, truly understood that actions have consequences and that resources aren't infinite? What could we build if they truly understood the simple concept of using something